probability. So there's a bunch of your formulas. Conditional probability, sometimes called Bayes' formula. Given a certain event, so this is probability of A, given that you know B happens. So that's a probability of A and B divided by probability of B. And this allows you to rearrange your this formula is just a rearrangement of your probability of A and B formula. Mutually exclusive is when the two things don't overlap. Independent is when one does not affect the other, and it just so happens that the probability of A and B is always equal to probability of A times probability of B. This also means that probability of A, given that B happened, does not matter. It's still the probability of A. Can't be mutually exclusive and independent at the same time, because independent, you will always multiply them together and get something, so you'll have something in the middle. We've got distributions, where a binomial distribution, formula for a binomial distribution, and the chart that you make. Things on your calculator, binom PDF and binom CDF. Binom PDF finds an exact probability. Binom CDF adds up to, and then you'll be usually using that if they say how many have at least this. Expectation for binomial distribution is just the mean number of trials times the probability of success. And here we have our normal distribution. Buttons you'll need are normal CDF and inverse norm, and also sometimes you need to use inverse norm with the Z-score formula. Okay, so with that, here we go. Okay, let's start. Two events such that probability A is 0.2, probability A or B is 0.5. Given that A and B are mutually exclusive, find the probability of B. Well, then it's just going to be the fact that both of them together, okay? The middle part is separate, so that'll tell you that the other part just has to be 0.3. You might want to draw a Venn diagram of this situation. If they're mutually exclusive, A and B are separate, and you know that A is 0.2, and A or B is just adding those sections up, that would also tell you that it has to be 0.3 for probability of B. Now, given that they're independent, so independent would look more like this, and an independent probability of A and B is equal to probability of A times probability of B. And what do we know? We know that 0.05 is A or B. A or B will be A plus B minus A and B. So if we write that out with what we know, right? So what I'm doing here is I'll write it right above so you have it. This is probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. What that's doing in your Venn diagram is it's saying if you add them both up, you add the middle twice, so you have to subtract it. Then plugging in everything that you know, the only thing left to solve for is the probability of B, and you can solve for that to get 3/8. Here's a probability distribution chart. Find the value of K. What do you know about a probability distribution chart? The probabilities always have to add up to 100% or 1. So when adding them all up, you can combine your like terms and solve for K, and you'll get 0.2. Then to find the expected value will be the X times the probability for each of them. So 0 times 0.3, 2 times 0.25 times 0.49 times 0.1, your expected value is 3.3. If the expected value is 1.7, find Q. So what do we know? We know that these three together have to add up to be 1. So that gives you an equation that S plus Q is equal to 0.7. Since you know the expected value is 1.7, we can write that out. That gives you a second equation that S plus 3Q is 1.1. At this point, you can use substitution or elimination. Here I'm using elimination. Subtracted the two equations. I get negative 2Q equals negative 0.4, so Q is equal to 0.2. And then, of course, if you wanted to, you could find S to be 0.5. So in a question like this, where there are two things that you don't know, it's probably going to be a systems of equations question. What do you have to do for a systems of equations question? You need to find two different equations. So you had to use the fact that you knew this added up to 1 and the fact that it gave you the expected value to solve. All right, let's look at the next three. Venn diagram. So if you know probability of A is 0.3, that tells you all of the box of A. It doesn't allow you to put a value. Probability of A or B would be M and N and P, but probability of A and B lets you figure out N first. Once you've got that value of N, now you know this has to be 0.2. And since this adds up to 0.3, this has to be 0.3, leaving you with this one to be 0.4, because that's what's left. Now that we have this, we can write down the value of N, and P and Q are right there. Find the probability of B with the dash. That's not B. That's everything outside of the circle of B. If B is 0.4, then everything outside of that circle is 0.6. Box contains 6 red marbles, 2 blue marbles. Anna selects a marble from the box. She replaces the marble and selects a second marble. The fact that she's replacing the marble makes this an independent event. It doesn't matter what you pick the first time once you put that in. So write down the probability that the first marble selected is red. Well, there's 6 out of 8 or 3/4.
Hey, Mr. Chair, just a note. What are we doing tomorrow at the staff meeting? It says something about math.
Yeah, we're in charge of the presentation.
What we're doing?
Yeah, I've got an idea.
Oh, yeah.
We'll figure it out.
Yeah, Ali's got an activity already, so that Bill and okay, yeah, thank you. I remember now.
Yeah, and we can hash that out during that meeting. Okay, 2 red marbles, well, it'll be 3 out of 4 times 3 out of 4. Since it's independent, you can just multiply that together. Find the probability that 1 marble is red and 1 marble is blue. Now this has cases, because you could get red marble first, then blue. There's also the possibility you get blue marble first, then red. Even though they're the same numbers, you have to add those up to get the probability. So common mistake here is just getting a 12 out of 64 and not getting the same situation twice. Sometimes helpful for this is drawing a tree diagram, right? You could get blue or red, and then you could get blue or red, blue or red. And you could put the probabilities down for each of these. So this is 1 on 4, 3 on 4, 1 on 4, 3 on 4, 1 on 4, 3 on 4. So what is the probability that 1 is red and 1 is blue? Is this branch or those branches and you'd have to add up those two cases. Following diagram shows a circle separating three sectors A, B, and C. The angles are given as followed. So now we can figure out probabilities here based on those angles. Arrow spun. It cannot land on the lines in between the sectors. So you can't have this, oh, it is in between. That doesn't count. So section A, arrow lands in A, B lands in B, C lands in sector C, S is the arrow lands in a shaded region. Find the probability of B. Well, 120 out of 360 degrees is a 1/3 chance. Probability of S, add the 90 and the 120 together, that is a 210 out of 360, a 7 out of 12 chance. Then C is saying, what's the probability that it lands in A given that you know it landed in the shaded region? So you could use your formula, or you could just look at it. Sometimes conditional probability you can just look at. You see the chances of it being in A is 90. The chances of all the shaded area is 210. So you could do 90 out of 210, or you could use the formula. A and shaded would be 90 out of 360. Probability of shaded is 210 out of 360. And it simplifies to the same value. First of all, 7 here. 88 boys, 32 study economics, 28 study history, and 39 do not study any. So the 39 is already out there. This information is represented by the following Venn diagram. Okay, calculate the volume values of A, B, and C. So what do we have here? 80, 32. We know that all of this, so A plus B is 32. Okay, we can put the following in. We can choose a value like the middle is going to be X. And then since A and B is 32, this will be 32 minus X. And since B and C is 28, that'll be 28 minus X. And if you add these all together and solve, what you can do is you can say that I can add this plus this. It has to equal from, so if I do the 32 minus X, and the X was 28, minus X, that has to equal the values there. And you can solve for this equation. Because you know there's 88 in total, so there's going to be 49 in those 3 boxes in the middle. Okay? Another way that you could look at this is right now if you add the economics and the history together, you're going to get 60. That's too much. How much is it supposed to be? It's supposed to be 49. What have you counted twice? You counted the middle twice. So then you counted extra by 11. You could use that to figure out that that middle value is 11. Okay, so student is selected at random. Probability studies both economics and history. That's the 11 in the middle out of the total of 88. Given, so anytime you have this given, it's going to be conditional probability. Given he studies economics, calculate probability, not history. Well, not history and economics would be, not history is anything outside of history, and economics is the 21. That's 21 out of 88. Probability of economics is the 32 students out of the 88. Together, that makes 21 out of 32. And this is very typical. We go from one type of question into a different branch of probability and statistics. A group of 3 students is selected at random from the school. Calculate the probability that none of these study economics. So student number 1 not studying economics is 56 out of 88. Now you can't choose the same student again, so now it's 55 out of 87, and then 54 out of 86. Calculate the probability that at least one of these students studies economics. Well, at least one, it's probably easier to calculate how many study none and subtract that from 100%. So we already calculated how many do none. We can subtract that from 1, and you would get 932 out of 1247, or 0.747. Okay, jar A contains 3 red, jar B 5 green. 2 marbles are drawn one after the other without replacement. So find the probability that none are green. This is probably of red and red. First will be 3 out of 8, and then since it's not replaced, the second is 2 out of 7. Exactly 1 marble is green. You have 2 cases, red and green, or green and red. Add those 2 cases up, and you'll get 30 out of 56. Find the expected number of green marbles drawn from the jar. So to figure out your expected value, you could have got 0 green marbles, 1 green marble, or 2 green marbles. We already figured out the probability of 0. That's 6 out of 56, but you times that by 0, so it really doesn't matter if you got it right or wrong. Then the probability of getting 1 was 30 out of 56. That leaves 20 out of 56 for the probability of getting 2. Multiply those out and add, your expected value is 1.25. Then jar B contains 6 red marbles, 2 green marbles, and a 6-sided die is tossed. If it's a 1 or 2, a marble is drawn from jar A. Otherwise, a marble is drawn from jar B. Write down the probability that the marble is drawn from jar B. Well, that's 4 out of 6. Given that it was drawn from jar B, write down the probability that it's red. Well, if you know that you're getting jar B, the probability of it's red is just 6 out of 8. So the interesting thing about conditional probability is sometimes you get conditional probability where, like in this situation, you are first choosing jar A or B, and then red or green, and jar A is 1 out of 3, and jar B is 2 out of 3. Then in jar A, the red one was 3 out of 8, the green one 5 out of 8. And jar B, the red one was 6 out of 8, the green one was 2 out of 8. In conditional probability, there's sort of 2 situations. What we have in part 2 of C is it tells you that it was drawn from jar B. What's the probability it's red? It's obvious, because now it's just 6 out of 8. The harder conditional probability is when you have to work backwards in time. If I told you I drew a red one, what are the chances it came from jar B? Is a harder conditional probability. If you're working this way and I say, you got jar A, what are your chances? Well, it's obvious. But if I tell you something now and try to figure out something in the past, that's a harder conditional probability. And that's what they have in part D. Given the marble is red, find the probability that was drawn from jar A. This is conditional probability that's more complicated. You have to figure out the probability of jar A and red, which will be the 1/3 times the 3/8. The probability of it being red are 2 cases. You add those up and solve for your probability there. Sorry, the numbers are so small. Wow, that's not what I wanted to do. And question number 9. Here we have replacements, so these are independent. Find the probability that x equals 0 and x is the number of gold balls. So this is the same as probability of not gold, or you could write it as probability of silver and silver. 6 out of 10 times 6 out of 10, 9 out of 25. The probability that you get 1 gold, you'd have to think about cases. You could get gold and then silver, or silver and then gold. Again, add those two cases up, you get 48 out of 100. Find the expected value. So you have 0 times 9 out of 25, 48 out of 100 times 1, and the remaining 16 out of 100 times 2. So you can find that 16 out of 100 two different ways. Either you can do 4 out of 10 times 4 out of 10, or you could just see what's left after you've used up the other percentages, because they have to add up to 1. 14 balls are drawn from the bag with replacement. So now we've got a binomial distribution, because we have a certain number of trials and a probability of success. Find the probability that exactly 5 of the balls are gold. That's binomipedia, because you're finding exactly 5. 14 trials, probability of success, 4 to 10. You want exactly 5, you get 0.207. Find the probability that at most 5, this is at most, so binom CDF. Okay, 14 trials, 4 out of 10, and when you plug in a 5 in there, it will count 0, 1, 2, 3, 4, and 5, and add them up. Then in part D, given that at most 5 of the balls are gold, find the probability that exactly 5 were gold. Well, if we set up our formula, it's going to be the probability of exactly 5 and at most 5 divided by the probability of at most 5. And we figured out these values already. 5 gold and at most 5 will be the same as 5 gold. And at most 5, we calculated that, so now we're just dividing the two together and get 0.43. Question number 10. Just divided into 3 equal sectors, A, B, and C, as shown in the diagram. An arrow spun. Okay. Each time the letter of the sector that arrow points to is recorded. Okay. So list the sample space. What could you get? It's spun twice. You could get A twice, A, B, A, C, B, C, B, B, and so on and so forth. If we wanted to count this, you have 3 choices for your first letter, right? You could use your fundamental counting principle. 3 choices. You should have 9 total in your sample space in the end. So you could use that as from grade 12 to make sure that you've listed them all. It could be systematic. If you drew a tree diagram, is a nice way of being systematic here. And of course, the first branch would be AA, the second branch AB, AC, and so on. And this would be a nice way of listing all 9 of them instead of just trying to think them through. Okay? Calculate the probability that both letters are the same. Okay? Well, there's 9 of them in total. 3 of them have both letters the same, so that's just 3 out of 9, or 1/3. Okay? At least 1 letter is an A. The nice thing about listing them is now you can just count. How many have at least 1 A? 5 out of the 9. At least 1 letter is an A, and both letters are the same. But that word "and" here, can you see that the only one that has at least 1 A and both letters the same is the AA, making it 1 in 9. at least one letter is A or both letters are the same. The word or, now you could have either of those situations. So I could have both letters the same, which I've already circled in black. One letter being an A, which I'm going to circle here. Those are those 5. Adding those all up makes 7 out of 9 in total. Because it says or. It's not okay just to add. Okay? You can't just add the 3 and 9 and the 5 and 9 together, because then you'll have counted the one that I circled in green and black twice. So you'd have to subtract that one. But in this situation, it's probably easiest just to go off the diagrams and count. This is a long question. Okay, part 2. 2 boxes, M and N, contain red and green marbles. Box N contains 5 red and 3 green. Box N 4 red and 6 green. Ball is taken at random from box M and moved into box N. A ball is then taken at random from box N. So here is the tree diagram. If you took a red one out, then you put it into box N. Box N now has 11 marbles instead of 10, and 5 of them are red, but 6 of them are still green, and so forth. Calculate the probability that a ball taken from box N is green. You could either pull a red one first and then a green, or a green one and then a green one. Adding up those 2 cases gives you 51 out of 88. And given that a ball taken from box N is green, find the probability that the ball taken from box M is red. So you want probability of a red one from M given a green one from N. Notation here is terrible, lots of letters. Probability of M, R, and NG. So you want the probability of pulling a red one and then a green one. That's 5 8s and 6 11s. Probability of getting your green one, we figured out in part A, 51 out of 88. Simplify that fraction, and you get your probability. Number of hours of sleep of 21 students are shown in the frequency table below. Okay? Find the median. If there are 21 students, which student is in the middle? Student number 11. Okay? How do you find the middle number? You can always do number plus 1 divided by 2. Okay? Where is the 11th student? 2, we're at 7. 11 students would be right here. So that would be 6 hours. The lower quartile. Okay, how do we find the lower quartile? Find its position by doing n plus 1 divided by 4. We do 22 divided by 4. What do you get? 5 point, right? Oh, not 22. Yeah, 22 divided by 4 is 5.5. So you're going to find in between the 5th and the 6th student, but they're both 5s. So it averages out to be both 5. Interquartile range, you'd also have to find Q3. Q3, the upper quartile, will be 5.5 times 3, which is 16.5. 16.5, where are we at? 7, 11, 14. 16 and 17 both happen in there. So quartile 3 will be 8. And then the interquartile range will just be 8 minus 5 for 3 hours. And our last question. Consider the following frequency table. We've got a cumulative frequency, so notice that this number here is always this. 2 plus 10 is 12. 12 plus 14 is 26. 26 plus what is 35? That tells us that P has to be 9. find the mean, type this into your calculator, right? You got your values here, and your frequencies in list 2. And then do 1 bar stats with list 1 and list 2 to get that mean. And the variance will be sigma squared. So you'll find your sigma, this symbol right there, to find sigma to be 11.02. You would square that, and to 3 sig figs get 121. And that is where we will start.